Good morning. Today I'm going to present you my Physics 2212 lab number 1 about charge tapes. The purpose of this lab is to exemplify the physics behind Coulomb's law and electric fields and how these can make charged objects attract or repel. Coulomb's law is this on the left and the electric field is this on the right. Coulomb's law describes how an object with a charge reacts with an electric field and produces attraction or repulsion, and the electric fields describe how charged objects create electric fields. So now the experiment. The object selected to analyze was a tape. The position of the center of mass of the tape was tracked. The distance lifted was measured with a ruler. The origin was set to the position of the lower tape. Here's a video of the experiment, where the lower tape exerted an electric force on the upper tape, repelling it. The system and the surroundings in this experiment. The systems is the upper tape, and the surroundings are the lower tape and earth, which the earth exerted a downwards force on the tape and the electric force exerted an upward force on the tape. Now the description of the computational model. The distance between the tapes was 1.5 centimeters. The gravitational force was calculated with a mass of 0.25 grams. With this, the model calculated an equal in magnitude but opposite in direction electric force to keep it floating. Now here's a video of the computational model with the code and all the data recorded by it. The comparison between the computational model and the real-life experiment. The similarities are that both have the same tape charge of 0.83 times 10 to the 9. The differences are that in real life the tapes didn't move straight and they also aren't a point charge. This was the formula used to calculate the electric charge on the tapes. The possible sources of error are that the measurements of the distance and the weight could have been wrong, and the assumptions for this experiment was that we ignored a resistance on a moving object, treated a long tape as though it were a point charge, with all the charge concentrated at the center of the long tape, and assumed that each U-tape we made had about the same amount of charge, evenly distributed along the length of the tape. So what if electrons had positive charge and protons have negative charge? What would change about the observations you made with your tapes and other charged objects? The observations would still remain the same. The charges of both tapes would have just been flipped in sign, and because same sign charges repelled, the tapes would still repel each other. Why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? When the charged tapes touch our hands, some of their charge dissipates and transfers to us. Therefore, we have to touch it as little as possible to keep the tapes charged. Here's the link to my simulation and the computational model, and thank you.